Alright, hi year 11s, this is Mr. Lim here again, and this is our 10th video on chemical bonding, a nice short one on covalent networks. Okay, so let's get started. We're going to be learning about how covalent network substances and their properties link to their structure. Okay, so covalent network substances are substances that are made up of atoms that are covalently bonded together, but not in small groups of atoms. Okay, so last couple of videos we've been dealing with covalent molecular substances where they're small groups bonded together, but this one instead is now a network which is not bonded in small groups. Okay, so instead they make one large superstructure or network of atoms which are all covalently bonded together. Okay, they're all covalently bonded together. Right, so if you remembered, the molecules, they're covalently bonded together, but instead, and then they have weak intermolecular forces or van der Waals forces, but instead covalent network substances, they're all covalently bonded together. Okay, since they're all covalently bonded together, they are all held together by strong covalent bonds. So we try and remember from the covalent molecular substances, they have strong intramolecular bonds within the atoms, those are the covalent bonds. And then you have weak intermolecular bonds, which are the bonds between molecules which are weak. But because there are no molecules here, because everything is covalent bonded together for a covalent network substance, it means that all of them will be held together by strong covalent bonds, and therefore that will make a difference to their melting boiling point and their general hardness and strength. Okay, covalent network substances are generally made up of substances in group 14, so that's carbon and silicon and other stuff, because they have the ability to form 4 covalent bonds. 4 covalent bonds is useful because you need as many covalent bonds as you can to make a network structure. All right, so let's have a look here. Covalent network substances come in a range of different arrangements. Okay, so they don't just come in one particular arrangement. They have a range of different arrangements, and they have different properties depending on those arrangements. Okay, so therefore, you can't just say all covalent network substances are like one particular way. They have a range of arrangements that say how they will exist. Okay, but in general, they have very high melting and boiling points because all of the atoms are in strong covalent bonds with each other, which means that they require a large amount of energy to overcome. And in fact, they're more likely to decompose or burn or just break down than they are to just melt. Okay, so they're not likely to actually melt, they're likely to decompose. Okay, covalent network substances are generally brittle because of the network structure, and the strong covalent bonds do not allow the atoms to move far from their original positions without breaking the network. Okay, so effectively, if you can't move far from your original position because you're being held by covalent bonds, and if you keep on pushing until they force it to move, you're likely to just break all of those covalent bonds, and therefore you've broken your substance, and therefore you are not malleable and brittle instead. Okay, and so therefore, and also covalent substances generally do not conduct electricity in solid or molten forms, generally because, molten form they can't get to, and solid form they have no mobile charge carriers because they're not ions, and all of the electrons are taken up in covalent bonds and thus not able to move. Right. However, these are general properties of covalent networks. And if you really have to read more about the different allotropes of carbon, which we'll learn about in the next video, or about the substance that's in the question, for you to work out whether it will conduct electricity or not. Okay, because not all of them follow the generalizations. Right. So some of them will be different. You have to read it and understand it to know that, there's a mobile charge carrier. There are some weak forces between things, so therefore it's going to act differently. All right, and so that is the concept there. Okay, so make sure you watch the next video, memorize the allotropes of carbon and what they do, and then you'll have a better understanding of the different covalent networks. Adios.